So today we're going to look at two-way tables and tree diagrams as part of probability. Some of you will remember this from last year, some of you may not have had a chance to cover it with your teachers last year. So first of all, two-way tables. Two-way table is a way to organise the outcomes of two trials that take place at any one time. So for example, here we have two die are thrown. We need to list the sample space in a two-way table. So how will we go about doing that? Well, first of all, one of our trials will go on the top line. So let's say we'll call this dice 1. We'll go across here. So we have 1, 2, 3, 4, 5, 6. And then dice 2 will go down this way and we have 1, 2, 3, 4, 5, 6. And it's a good idea to kind of just put this into a kind of grid format so that you can separate the outcomes. So like so. And what we have here is if I roll dice 1, I can get, I'm actually just going to change that little bit around. I think D1 we'll work from this side first, so D1 and D2. So the first roll of the die, I get 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. So they're the possible outcomes. If the first die lands on 1, then all the possible outcomes that could happen for dice 2. Okay, and you just fill that in the whole way down. So again, I get 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. You can pause the video here to check your answers. I've just gone ahead and filled them all in. Okay, so that's our sample space, listing the sample space in the two-way table. They could also ask us to list the total value of the numbers on the die, so I'm just going to show you that in the next slide. So you can pause the video here if you want to take down this table. It's the exact same table that we had in the last slide. But just to show you, if they asked for list the score in a two-way table when when two dice are thrown, well, the score is the sum of the sides of the dice. So you can see here you have 1 and 1 is 2, 1 and 2 is 3, 1 and 3 is 4, 1 and 4 is 5, 1 and 5 is 6, 1 and 6 is 7, and you can continue the whole way down. So 2 and 1 is 3, 4, 5, 6, 7, 8, 4, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 11, and then 7, 8, 9, 10, 11, and 12. Okay, so that's our scores. So then they could ask something like, what's the possibility of getting, so what's the probability of getting a score of 7? So you can see here that our 7s, we have a total of 6 of them. And our total outcomes, so we can see that there's 6 7s. And remember our total outcomes, so we have 6 by 6, which is 36. So that gives me 1 over 6. That's my probability of that event occurring. If we take another example, let's say the probability of an odd number. So if we look at the probability of an odd number, we can see that odd numbers, so let's highlight them. We have 3s, we have 5s, we have 7s, we have 9s, and we have 11s. So 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 odd numbers in total. And we know that our total number is 36 of outcomes. And I only got that by just counting all of these, or 6 multiplied by 6 will give me 36. So 18 of 36, which is exactly 1/2. Yeah, Okay, so that's a nice way of being able to find out the answer for probability listing things in a two-way table. Okay, so a tree diagram then, some of my guys will remember this from last year. A tree diagram is just another way to graphically display two or more trials occurring at any time. So if we're trying to find out the different, let's say the sample space of the different possibilities with a menu. So here we have a menu with a starter, dessert and main course, and we want to see all the different combinations that we can get from that. So if we look to start off with, we have two starters. The first one being soup, and I'm just going to put S as soup, and GB is garlic bread. Looking at that, we can have, I'm just going to make that a bit smaller because I will be tight for space. Okay, looking at that then, if we have soup, we have three options of main course. So we have a burger, we have a curry, or we have lasagna. And similarly, if we go with garlic bread, we have a burger, curry and lasagna. And then finally, for all of those, we only have one option of dessert, so that's chocolate cake. Or we could have no dessert either. Okay, but let's pretend that we have to pick all three. So now we can see by looking here the different number of opportunities. We can tell from the very last leaf or the very last stem of our tree, that tells me there's 6 possible outcomes. Or combinations. Okay, and when we're reading it, we can read it like this. So we have soup, burger, chocolate dessert, chocolate cake, soup, curry, chocolate cake, soup, lasagna, chocolate cake, garlic bread, burger, chocolate cake, garlic bread, curry, chocolate cake, and garlic bread, lasagna, chocolate cake. Okay, so a tree diagram just shows really nicely how to put that in a kind of table, but also give us all the possible outcomes. Okay, so let's take another example there, because I know that tree diagrams are always the ones that catch people out. So we have toss a coin 3 times. So if we look at the first time we toss the coin, we are going to get 2 outcomes, heads or tails. The second time we toss the coin, we are going to get 2 outcomes. So it's either going to be heads, 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 tails, or it's going to be tails, head, tails, tails. And for the third time we toss that coin, so we now are going to have heads or tails. So that would give me heads, 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 tails. Or we are going to have heads or tails here. So we get heads, tails, heads, heads, tails, tails. We can also have, so if we just put out a little longer arm here, we could also have tails on the first trial. So tails, heads, heads, tails, heads, tails. And the very final one then we have, so we could have tails, tails, heads, tails, tails, tails. And if I count up those, I have 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes.